Hello, class. Today we are going to be discovering and exploring the angle relationships created in transversal lines and the angle relationships that can be observed in triangles. Part 1 has you record observations about angles and transversal lines. With your partner, manipulate the angles and discuss what you notice. When writing, use appropriate vocabulary.
It looks like the angles in the same place on each line are always congruent.
Those are called corresponding angles. They are only equal going down, not across. I wonder why.
I noticed that the horizontal lines are parallel, but the vertical lines are not. The angles that stay equal are on the parallel lines. Maybe that is important.
These angles that are adjacent to each other are supplementary. Since these angles are congruent, I wonder if those angles are supplementary too.
Yeah, it looks like the same side interior angles always add up to 180 degrees. I knew those angles were supplementary because I know that vertical angles are equal, but I don't see any other relationships.
Justin, you are saying that you see many pairs of vertical angles. Do you think you can describe the location of some of those angles?
Well, these angles that are outside the lines are equal all the time.
That's right. Are those equal angles on the same side of the line they are touching, or are they on opposite sides?
They're on opposite sides, like alternate exterior angles, except here they are always equal.
It must be because these three lines are parallel. Look, the alternate interior angles are congruent too.
Excellent. You all go on to part 2 to see what you have learned. Take a moment to check your work from parts 1 and 2. Then, work on part 3 of your task. You will be exploring the interior and exterior angles of triangles.
I see that the green and pink angles always stay the same size. One green angle is inside the triangle and the other green angle is outside. The same is true for the pink angle.
Look, those two outside angles make a straight line with the last triangle angle. Maybe those two of the triangles inside angles add up to the outside angle.
Let's build our own triangle so we can use measurements to see if that is true.
I think we could prove these angles are congruent by adding a parallel line to this picture. The green angles would be alternate interior, and the pink angles are corresponding.
I agree. It also looks like the two interior angles make the exterior angle. Do you think that works on all sides of the triangle?
I'll get started on our new construction. I'm going to start with two parallel lines, then I'll make the triangle inside them, and extend the edges.
All right, class, let's come together and share with each other what we have discovered today. Let's have Tom come up first and share for his group.
Our group noticed that a triangle can be inscribed inside a set of parallel lines, which proves that the angles we are studying will always be congruent. This also helped us see that the interior angles across from the exterior angle always sum the exterior angle. You can see it in our picture right here.
Excellent observation, Tom and Justin. Let's give Julie's group the opportunity to expand on that.
First, we would like to point out that this diagram does a good job showing that all the angles in the triangle equal 180 degrees. Since we know that all of the angles in the triangle equal 180, we drew the following conclusions. Red plus blue equals 180 minus green. The same is true for the other angles. If we took the red angle out, we could figure it out by subtracting the sum of the other two angles from 180 degrees. Since the red angle and angle P are making a straight line, angle P has to be equal to the sum of the blue and green angles.
Mrs., I think I can help Julie show and explain our thinking here. Here we are showing that angle P and the red angle make a straight line, which is 180 degrees. When you subtract the red angle, you are left with angle P. Since the triangle has 180 degrees inside, when you subtract the red angle you are left with green and blue. That means angle P is equal to the sum of the green and blue angles.
The same is true if you take away the green angle and the blue angle. Angle Q is equal to red plus blue, and angle R is equal to red plus green. That means that an exterior angle is equal to the sum of the interior angles across from it.
Excellent job, Joey and Julie. Class, I would like for you to take out your notebooks and reflect on the key points you took away from today's exploration. Justin, before we go, will you please share your summary of today's lesson with the class?
First, we saw that parallel lines cut by a transversal make several angle pair relationships. Then, we started looking at triangles and found the inside angles some 180 degrees. Finally, we noticed that the exterior angles of a triangle are equal to the sum of the interior angles across from it.
Thank you, Justin. Great work today, class. Have a great afternoon.